What's up, guys? Welcome back to the eCoreAcademy e-learning platform today. My name is AJay back with another geometry course video for you guys. And before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as hitting that post notification bell to get notified on any of our channel's latest posts at eCoreAcademy. Today's lesson topic is all about basic geometric terms and definitions. This is a very fundamental and basic lesson for you all. It's very key that we get into this lesson and that you take notes on all of the definitions and terms that I'm going to throw at you throughout this presentation. I will try my best to break apart each and every one of these definitions, but if you don't understand them to the fullest, do not worry. We will come across certain lessons and topics where they will be put into action with specific lesson problems. So, like I said, this is a very fundamental lesson. This is supposed to be the very first lesson of our entire geometry course. So if you already started watching previous geometry videos, or if you're just tuning into our geometry course at eCoreAcademy, please make sure to watch this video first and prioritize it first, because it's useful that you get this information now, soak it in, so that later on, higher level concepts, you won't be confused with all of these mentioning terms that I will be throwing at you, because you will be expected to know that if you're taking this in an actual school. So the whole purpose of today's lesson is discovering what are the fundamental items and concepts in geometry. So we need to discover that before we move on in any other aspect. All of these concepts, high-level relationships, they all originate around these basic ideas, and we'll build off of that later on. But let's get to these basic geometric definitions and terms. And I would strongly recommend that you have some form of note-taking, either digital or pen and paper. I will be hand drawing examples for each and every definition that I throw at you. And if you need to, pause the video to jot down these notes, because it's very important that you get this information down. All right, let's get right into it. The very first term that we have is a point. So we're going to discover what a point is. And the definition of a point is a location in space with no length, width, or depth. So you might be thinking, wow, I already know what a point is, but why does it have such a complex definition? That's because in geometry, a point represents any specific location. A point itself is not necessarily an existent figure. It doesn't count as a figure because it has no length, depth, or width, so its entire area and volume would be zero, so it would not take up any space in general. However, it would just be pointing out a specific location. Like a point on a map would be pointing out a specific, say for example, a specific road or, restaurant. But the thing is, that point would not be there in real life. And it is the very standard unit in geometry. It's the basis of all figures and all lines, all of these visuals in geometry. It's where everything originates from, but yet it's non-existent, because a point in general only shows a location and not necessarily a standard figure. So this is what a point looks like. It's very generic. You may have already heard of it. So a point is just a dot in space. It's mostly represented by a circle, and you can also name that dot by any letter. Normally, we work with A, B, C, D, and X, Y, Z. Those are the most common vertices and naming points in geometry. So we're going to name this point A. It's very straightforward. And then we're going to move on to what a line is. Now, a line is basically just building up off of what a point is. It's just extension. It's just another extension of it. And as we progress throughout this entire video, we're going to be differing in our level of difficulty, meaning we're going to start at very generic and basic, and we're going to be moving on to much more complex topics. Not necessarily that they're all very complex, but it's just going to increase in complexity. And they're going to build up off of each other. So a line is just going to build up off of what a point is. And a line is a collection of points arranged in a straight path, and it basically extends out infinitely in both directions. So a line is strictly defined by two of its given points. And I just want to give you little bits that you need to know about a line to fully understand it. A line is basically what you've heard of. It's a straight figure. It's a straight line. It's something that comes parallel, and it's an intersection of any two-dimensional platform that you're given. And that line actually extends for an infinite period of time. What you see on the paper is not necessarily the entire length. So since it increases infinitely, you cannot calculate the length of a line. It's infinite. It's just said infinite. And all lines have the same length just because of that reason. And a line is strictly defined by two of its given points. So say, for example, we have two dots here, two points. We're going to build up off of what a point is. So if we're given 2 points, we're going to name them A and B. Now, if we're said that if we're given a line, basically any extension of straight figure, and we're said that a line intersects A and B, that means the name of the line is line AB. And as you can see here, a line intersects 2 points, 2 defined points. And these arrowheads at the end of this line just show that this line extends for infinite reach. It has infinite length and extends infinitely. Infinite. I'm just going to write that there. That's the most important thing about a line. And basically how you would write this in geometry, how to abbreviate what this whole concept here is, it would be line AB because it's the 2 points that define that line. So you'd write point A, point B, and then you just draw a line over top it. And then that represents line AB. For the third definition that we have is we're going to discover what a plane is. So we started off with what a point was, what a line was. Now we're going to move on to what a plane is, which is a bit more complex of a figure. So what is a plane? A plane is a flat surface in which extends infinitely in all directions and has no thickness. So that's basically what all two-dimensional figures are based off of. They're based off of a plane concept, and it's not a plane like an airplane. It's a plane meaning like, say for example, you're on farmland and a flat terrain. That entire flat terrain would be considered a plane. And a plane, like I said, has no thickness, and it's a flat two-dimensional figure, and it extends in all directions. So I'm just going to draw that for you. So say for example, we have lines making up this plane, and I'm going to make this plane a parallelogram, or a rectangle, but just keep in mind that a plane can be any figure, any singular figure that you want it to be. It's oftentimes a rectangle, a square, or a parallelogram, but a plane can be any sort of shape that you want it to be, because the reason being is all planes have the same exact area, because if they're extending infinitely in all directions, they're going to end up with the same exact area, and if they have the same exact area, they are the same exact figure in this case, since they're going to extend in all directions with the same amount. So they're all going to total out to being the same exact object, no matter what it is. They're just all similar. So it doesn't matter the starting plane that you're given, they're all going to end up the same. So I'm just going to use a rectangle as reference here. And as you can see here, it's extending infinitely. I use those lines. But in every direction, this is just extending out. And basically, if this whole screen here was a plane, it would just be extending out infinitely and increasing infinitely. Now, a plane is very key, and it's a bit confusing because we refer to planes in three-dimensional references, but they are two-dimensional figures. So if you're given a plane, a flat surface, and say, for example, it intersects where your wall comes down directly vertically and perpendicularly to your floor, that would be one plane, and all of its distance that covers from side to side would be infinite, and up, down would be infinite. However, if you shift that line backwards like 1 inch or so, that would be a completely different plane. And that's very important to know, and I will get into that in later lessons, the specifics of it. Now we're going to move on to what a line segment is. So we're going to ask ourselves, what is a line segment? You probably have heard of what a line segment is. You probably haven't necessarily come across what a line is in real life, because it's a non-existent thing in real life. Nothing can extend infinitely in real life, but it can in geometry. But a line segment is basically a line. It's often just referred to as a line. And a line segment, aka a line in real life, is a part of a line. It's very important to see that it's a part of a line that consists of any 2 points on the line and all points in between them. So I'll show you what that is. So if you're given a line, because we already know what a line is, if you're given a line like this, and you're given line AB with, excuse that arrow, you're given line AB with 2 points A and point B, the way to figure out what a line segment on AB would be is you have to basically you're erasing off these infinite extensions of A and B, and once you erase that, you're left off with point A and point B and the distance between them. And since you're given point A, point B, and the specific distance between them, you're given a line segment. And a line segment has a definite length, and I'm just going to show you here. Segment has a definite length. That says a definite length. So I'm just going to write that here, definite for length. It's a complete opposite of a line, but it's important to see that a line segment is always a certain cutoff or a certain section or portion of a line given with those same existent points. So that's line segment AB as shown. And now we're going to find out what is array. We're going to discover what array is. So array is a part of a line that has an endpoint and extends infinitely in one direction. So just to dumb that down for you all, this is basically a hybrid between a line and a line segment. So if you were given a line and a line segment with the same exact similar point, so we'll say that this is a line here, and we'll say that this is a line segment. Both are complete opposites from each other. But what array does is basically it takes a point on a line, or takes a line segment and a line, and basically meshes them both together. So you're given a point and then a side that extends infinitely. So that's what array looks like right here. And if you're viewing that in terms of what a line is, you're basically taking one point on a line like this, and you're erasing off one side of that line. One side of that point off, and you're left off with a point extending infinitely in only one direction and not both directions. So in turn, array is equivalent to half of a line. And then we're going to discover what an angle is. So what is an angle? An angle is a figure formed by two rays that share the same endpoint. So an angle measure is basically an extension off of a ray. Like I said, we're going to be extending off of each and every term to its predecessing term. So if we're given two rays and they intersect at one similar point, there's a little figure that I'm going to show you. It's an arc that's formed, and that's called your angle. And an angle is, I'm sure you've heard of it. It's very hard to explain if you haven't come across it, but an angle is merely just measured in degrees or radians when two rays intersect, and I'm going to show you what that looks like. So two rays intersect. So say, for example, you have this ray here with this endpoint, but and there's two rays that share the same endpoint, meaning that two rays come across from the same point, but they extend in opposite or different directions. And as you can see here, they make this little gap in between them right near that vertex, and what that near that little point there, and what that little arc that I drew here is called the angle. It's called your angle. And the angle is always going to be referred to in its angle measure, because you're not just going to have a similar angle, a plane angle, but you're going to have the angle in its measure, and most likely it's going to be in degrees, not like the degrees, in Celsius, centigrade, or Fahrenheit, but it's going to be in form of, 1 to infinite degrees. It's going to be expressed in form of a number. So that's the degree sign right here. So yeah, when you think of angle, you're going to think of measure most likely. Otherwise, you're going to be thinking about our next definition, which is a vertex. So a vertex is the common endpoint of two rays that form an angle. Like I showed you here, these are two rays intersecting right here, and this common point where they both share an endpoint, is where the vertex is created. So an angle is named by its vertex. And once you discover where two rays intersect, and you've named that vertex because two rays intersect at the same common point, and since an angle is formed, you can name the vertex. You can name the angle by the vertex that it's intersecting at. So say, for example, you have this ray here, and similar, just exact same picture that I hand wrote last time for the definition of an angle. We're going to have two rays that have a same extend from the same point. Since two rays extend from the same point, or any two line segments, that this would be considered a vertex and not just a single point, since there's two extensions from that single point. And as you can see here, this is the angle, right? Since this is an angle here, and it's obviously being represented by this vertex, since it's right next to this vertex, and if this vertex is named vertex A, that means that this angle is also named angle A, with a certain amount of degree measure or a radian measure. And what a radian is, it's another form of measuring or expressing a degree measure, and I will get into that later on, but it's a much more complex geometric concept to understand. And we're going to look at this next term, which is basically what is collinear. So collinear is it's a relationship between two different points, and I'll get into that. But as you can see here in the name root, it says line, and basically what it does is it uses a line to show whether or not 2 points have a certain specific relationship. So collinear is basically just a relationship between 2 points. And like I said here, collinear is by definition are points that lie on the very same line. Now we know that a line has an infinite collection of points, but we want to see if 2 specific points lie on the same line, and we want to know what that relationship is defined by. And collinear describes a relationship between 2 points and not aligned. So it uses a line to describe relationship between 2 points. So if we're given a line here, extending infinitely in both directions, and we're given 1 point here, point A, we want to discover if point B, which is on this line as well, is collinear to point A. And since they both exist on the same line, as it's obvious that they both exist on the same line, that means that both of these points represent collinearity or just being collinear. So A and B are collinear points since they both exist on the very same point, and they make line AB. And then our last 2 definitions, we have what is non-collinear. It's basically just the complete opposite of what collinear is, and non-collinear points are points that don't lie on the same line, as it has the prefix non, which is basically what any certain word starts with. Non represents a negation, which is basically saying not collinear or opposite of collinear. And what that's basically showing is if you have a line and you're given a point A, and you see that point B, it's not on the same line. Since it's not existent on the same line, that means that A and B are not collinear. So it's not collinear, which is basically saying non-collinear, since not equals non. And finally, we have what is coplanar. So as you can see here, collinear was used to show what was used to describe used a line to describe 2 points, a relationship between 2 points if they existed on the same line. But coplanar uses a plane to describe whether or not 2 points exist on the same plane. So it's basically coplanar points are points that lie on the same plane. So just ignore this line. It's supposed to say plane, Plane. And coplanar points are points that are on the same 2-dimensional outlook, and that's another way of phrasing a plane. Your 2-dimensional outlook is a certain given plane with its given dimensions that represents a certain large enough window to see whether or not 2 points are on the same plane. Since we know that planes extend infinitely, we have to have them within a reasonable reach to discover their coplanar properties. So if you're given a plane here, I'm going to make this a parallelogram like this. Extends infinitely. That's why I'm putting these arrowheads on them. Extends infinitely in all directions. And if I draw a point here, and I name it point A, and I draw another point here, point B, we are given with the task of defining what the relationship is. And since they're both on the same plane, they are both coplanar. But if you're saying are point A and point C coplanar, and you figure out that point C is definitely not on the same plane, that means they're non-coplanar or not coplanar. All right, guys, so that's it for today's lesson. I know it's a lot of information, but please make sure to jot down all these notes. It's very important that you master the fundamentals before you master the concepts that come later on. It's much easier to do it in that way. So that's it for today's lesson through our eCoreAcademy e-learning platform. Before you leave, please make sure to like and subscribe down below and hit that post notification bell. Now, I know this video had quite a lot of information in general, so please make sure to pause the video at any points, rewind this video if you need to make sure you write down and jot down all of the notes needed. All right, and talking about all of the notes that you might need throughout these lessons, throughout our eCoreAcademy e-learning platform courses, please visit our website link at eCoreAcademy.org, and there you get full unlocked access to all of our worksheets, quizzes, integrated quizzes, and note sheets that go along with each and every single video and are organized into course studies. So please visit there. It's a full unlocked access to everything that eCoreAcademy offers to you. And you can also always email us at our Gmail at eCoreAcademy@gmail.com if you have any questions or if you just want to reach out to us. And please visit all of our socials at Facebook, Twitter, and Instagram. It's greatly appreciated if you could share our videos through all of your platforms. So I hope you guys enjoyed. This is a very important lesson for you all. It's basically our opening into geometry, and I hope it goes smooth for us in the future. All right, guys. Hope you guys enjoyed. It's been AJ, and I will see you guys in the next one. Peace.